Welcome to a discussion of PCB Aroclor Analysis. I'd like to highlight very briefly some points in the EPA method 8082A, which covers polychlorinated biphenyls, PCBs as Aroclors, on either a single or dual column. Aroclors, of course, are multi-component mixtures, and what is of interest is the total PCBs, and also determining the weathered Aroclors. The technique which is used is to identify a PCB Aroclor based on the comparison of retention time of 5 selected quantitation peaks and the visual pattern recognition of comparing that to a reference library of PCB Aroclors. Typically, Aroclors have a 5-point initial calibration. Covered in another section is the chromatogram information window, which allows you to see these Aroclor patterns overlapped and then to pick the representative 5 peaks associated with each Aroclor and to create those compounds in your quantitation method. The purpose of compound math is to aggregate peaks. I'll show you in a moment a GC example, but it is equally applicable to mass spec signals. And what we're going to want to do is to take those signals and aggregate the calibration curve together. It's worth noting that this is best served by peaks that are non-contiguous. Otherwise, you might consider the spectral summation that would take the area between a retention start and a retention end. Let's take the specific case of Aroclor PCBs, and you can see here there's a dual column GC flame ionization detector. You can see that by the different colors, and that's what will be used here to show you the grouping with compound math. The Aroclor mixture 1016 is quantitated by picking 5 peaks that represent that particular Aroclor mixture and summing those together to produce an aggregate calibration curve. Let's take a look at the compound math setup in the method editor. And you can see here are the 5 peaks that I've chosen to represent that Aroclor 1016 mixture. I put them all into the same compound group, and I've created a new quote-unquote compound that will total them that shares that same compound group. That summation compound takes all the concentrations and sums them together into a total calibration curve. So here is the compound math result shown in batch at a glance with the GC quant flavor, which removes all the mass spec choices from the UI, so you won't see any spectral features. These are the 5 peaks that we just discussed that are shown together, extracted, and that sums to a total either by concentration or response. You can sum or average, and you can see here for the different samples I've got the total for the Aroclors of all the contributing aggregated peaks. Alright, now for the compound math demo. Here I am in the method editor with the compound groups set up for Aroclor 1016 and Aroclor 1260. So let me go over and analyze, and you'll see here are the results. I've got it filtered with the compound group to show the 1016, and there are the contributing peaks. I can see each one of them, and then the aggregate total with its calibration curve. Or I can filter on the 1260, and again I see each of the contributing peaks and then the total with the aggregated calibration curve. Thanks for your attention.